Encountering a new problem can be daunting, but sometimes just looking at an example can sharpen your intuition enough to solve it almost immediately. So, take this one problem that a student of mine came and asked me for help with. The problem says to show that for every integer n, there are integers a and b such that n squared is equal to a squared plus b squared minus ab. So after looking at this for a while, we seem to not be able to make much progress. Algebraically, it doesn't seem like much works. My student pointed out that this looks almost like a minus b squared, which is a squared plus b squared minus 2ab. But this 2 is difficult to get rid of. How do we get rid of that? Because that doesn't appear in the equation that we want to. Seems like no tricks really work here, so we're algebraically a little stuck. So I suggested to the student that we try some examples. I didn't know how to solve this either. So how about we just try a simple example like n equals 1? Can we find an a and a b that work in that equation above for n equals 1? So I encourage you to think about this yourself. There are a few that work, and come up with your own examples too if this one doesn't give you any inspiration. But the one I came up with was 1 squared is equal to 1 squared plus 1 squared minus 1 times 1. So in other words, A equals B. Is that a coincidence that A equals B? I think we've encountered something that can help us. So if I take A equals B in general, then A squared plus B squared minus AB is just A squared plus A squared minus A squared, which is A squared. So for any integer n, we could take a and b to be the same and be n, so that a squared plus b squared minus ab is just n squared plus n squared minus n squared, which is just n squared. Solving the problem.